Question 4. A car accelerates, so you could do your UVAST system. UVAST. Okay. A car accelerates 3 meters at 3 meters per second from rest. Rest means U equals 0. A to a speed of 60. V equals 60. It then travels at steady speed, so it changes what's happening each time. So this is T1 and this is S1. Okay? And then all of a sudden it changes what it's doing. Now all of a sudden in the middle part of the journey, so it accelerates really rapidly. Then in the middle part of the journey, it then decides to go at a constant velocity. Okay? So in the middle part you could say U2, V2. U2 and V2 are both 60. 60. And then A, S, and then T is 75. Okay? It finally decelerates to rest. So it comes back down to rest. And we know that is, at the end it's going to be U3 is 60. V3 is 0. A we don't know. S we don't know. And T3 we don't know. So you can see it's a lot different from the last one. There's lots of individual parts that haven't been done yet, so we don't know. Covering speed. Find the time spent decelerating, the total distance covered. Okay. So speed of 20, speed of 60, VT1. Alright, so guys, you can see what I suggest we use is what's called and we have distance at the end as well. So the distance is 150. Okay, so it wants to find the time spent decelerating. Now, you guys could use V equals U plus AT, couldn't you? Quite handily, yeah? And you could use 60 equals, oh sorry, not 60, that's 0. 0 equals 60. Now, we can use V equals U plus AT actually because we don't know what we don't know A and we don't know T. That's a problem, okay? So we'd have to go again and we could say, look, it's V squared equals U squared plus 2AS. And we can say that it's 0 equals 3,600. 2 times acceleration is 300A. And then bring the 3,600 over to the other side. And then divide it by 300. And we get A equals minus 12. You happy enough with that? Now, there's another way of looking at this, okay? And then once we find out A, what can we do after we find out A? We can then find out what T is, okay? And T would be V equals U plus AT. And then you could say, okay, it's 0, that's 60, that's minus 12T. Bring it over to the other side, 12T equals 60, T equals 5. So much shorter way. You can do that, but there's a much shorter way. Let me show you the much shorter way. The thing about distance time graphs is that the shape, the area underneath any part of your journey equals the distance covered. So this here is actually 150 meters. Okay? And then what we can say is that what's the height is 60, and this here is T3. The area of a triangle is a half base by height, so 60 times T3 equals 150. We're going to get 30 T3 equals 150. T3 equals 5. Which was easier? Using the area formula, it took me 5 seconds. The other one took me about a minute and a half. Okay? So that's the difference, alright? You can use area of anything you want to find it, okay? Now, what can you tell me about area 2, the rectangle? How much distance do you think is covered in the middle part? What's the size of it? It's 60 across and 75 wide. Yeah? because time is 675 across, height is 60. So 60 times 75. Thank you. 4,500. So 4,500 is what's covered in the middle section. Okay? And then it goes, find the distance covered during deceleration. So did we already find the distance covered during deceleration? We found out it was 100 and... Oh, sorry, what's the... Sorry? Oh, other question, right. Total distance covered. I was wondering, they already gave me that. Now, do you want to find the total distance covered? Okay? We know that that's 150, that's 4,800. Okay? And that leads us to this part here. 0, 60, A and S. We can find out what... we're missing a piece of information. Maybe the...
A is 3.
Sorry?
A is 3.
Ah, I can show you now. Okay. Does it say A is 3? Yeah, so I was missing a piece of information, okay? A is 3. So, what we can do here is, we can say that phi equals U plus AT, and then 60 equals AT, which is going to be 3T1. Okay, and then 3T1, T1 equals 20. Yeah, so it's accelerating for 20 seconds. Now that we know that this is 20, what's a half? 20 times 60. 600. And then finally the total distance covered, 600 plus 4,800, 5,400, and then plus 150, 5,550. Now, how do you get average speed, lads? Average speed? Sorry? Total distance over total time. So total distance is 5550. So total distance over total time, total D over total T, okay, is going to be, what's the total time? We found out what T3 is, didn't we? A couple minutes ago, I think it was 5. Yeah? So add it together and we get 100. And that means the average speed is 55.5 ms to the minus 1. Okay, I'm going to skip question 5 and go towards question, something a bit harder. I say question 9. So question 5 and question 9.
Sir, did you do that graph thing for any of these questions?
To know you're doing a graph, you'll see that it's in different, the one object will do different speeds at different times. That's how you know you're doing a graph question. Okay? So a cyclist covers 350 meters in 18 seconds. Starting from rest, he accelerates uniformly to a speed of 25 meters per second. He then continues at this speed for the rest of the distance. Calculate the time spent accelerating. So guys, what we have here is 2 different intervals. First interval, straight to the top. Second interval, you're staying at a constant speed. 2 different objects, a rectangle and a triangle. Because the same object undergoes 2 different scenarios in the one question, we automatically know it's a time graph question, a velocity time graph, okay? So, velocity here, time on the x-axis, okay? Now, what can you tell me about the area of the triangle plus the area of the rectangle? What can you tell me about that? What's the answer when you add both areas together? The answer is 350, because the area under both of them equals the distance covered. Okay? Now, we know that the total time is 18. Yeah? Can anybody suggest a time system we could use? If I say that this is T, if I say that T1 is T, what can I say about T2? What can I say about T2? yeah, so T1 plus T2 equals 18, and if I say that T1 is the same thing as T, so T1 is just T, then that makes T2 18 minus T. Yeah? So our system is going to be T and 18 minus T. Now, speed of 25. Okay, so what's the area of the triangle, lads? The area of the triangle? So a half 25 multiplied by T, and the area of the rectangle, length by width, that all equals 350. Then we're going to get a 12, what's a 12.5 T? 25 times 18, 4,000, what's it, 4,950 or something like that? Do it here. 450 minus 25T equals 350 minus 12.5T equals minus 100 when you bring the 450 over the other side. And then finally T equals what? 12? What? 8. 8 seconds. Okay, so that was 4B, or sorry, 2B, question 9. Okay, so what was it? 2B, question 9. Now, there we go. So T equals 8 was the full question, wasn't it? Calculate the time spent accelerating. It's going to be 8, and time spent at constant speed is 12. Okay guys, we have time for one more. So number 10 is going to be number 10. The maximum speed of a car is 40 meters per second. Its maximum acceleration is 2, and its maximum deceleration is 8. The car has to travel 700 meters from rest to rest. What is the minimum possible time? So, if it's a minimum possible time, what you're looking at is basically you're looking at this type of system here, where you have, oh wait a second, you're not looking at this at all, because you'll travel at no constant velocity, right? If you want to go from A to B as quickly as possible, you're going to go really, really fast, and then you're going to slam on the brakes last second, like a Formula 1 driver going into a corner. You're not going to stop at like 180 miles an hour. You're going to go all the way up to 200, and then jam on last second to get there as fast as possible. So that means that this middle section here doesn't exist. All right. So this time it's basically going straight up, and then straight back down again. Okay, so in effect we're dealing with two triangles this time around. That makes sense?
What if the car reaches its maximum speed?
Well, if it does, then it plateaus at the top. We'll only know by making an assumption, and then we can find out. Okay, so its maximum acceleration is 5, and its maximum deceleration is 8. Oh, sorry, was it? Deceleration is 8, acceleration is 2. We actually have to find out, does it plateau or not? Okay, because it actually might. So to figure out if I'm using this system or if I'm using a system with a plateau, what I suggest is we do this. I'll just do U fast, okay? And so we're not making any assumptions, right? So V0, does it start from rest? Yeah. And then the acceleration is 2. Okay. And then what do we have here? Yeah. Okay, I got it. Now, what I'm going to do is I'm going to find out how much time it takes for that to decelerate all the way down. That'll be 20 seconds here, right? Would you agree with that? So look, phi equals u plus at. 40 equals 0 plus Sorry, I don't know what t is yet. So 40 equals 2 times t equals 20. Takes 20 seconds to go to accelerate completely, right? And then I'm going to do the same thing for the deceleration. And for the deceleration, I'm going to find out, once again, using phi equals u plus at, I'm going to find out that it's going to be 0, 40 minus at, move it over to the other side, and then I'm going to get at equals 40, t equals 5. Now guys, if I was to calculate using triangles these two distances, I can do a half, that would be 20, and that one would be 5. So it would be a half, 20 times 40, which is what? 400. So 400 for the left triangle, and how much for the right triangle? A half, 40 times 5, which is 100. And as we now identified, how much distance are we short? So we're back to the initial graph. Okay? So we're back to actually having a plateau. So, excuse me a second. So we're back to actually having a middle period where you actually have to there'd be no way of knowing that until you actually did the numbers. Okay? So what we have here, probably should shift that a bit over here. Okay, so here we go. So there's our system there now, okay? Now, we've already discovered a lot of things about this. What did we discover about the first one? We've already discovered that this one here covers 400. We discovered that the last one pulls over 100. And then we discovered that this one here is 200. Okay? And then what we can do then is just put in our we know the times then, don't we? That's 20. The other one is 5. And I already what is the minimum possible time? So what is your time at maximum speed? 40. 200 divided by 40. Because you travel 200 meters and you have a speed of 40. What does that give you? 5 seconds. So t equals 5 seconds. So it's 20 plus 5 plus 5, and what will that get you? 30 seconds in total. Okay? Now, the other way to have done the other way to do it would have been to, it's actually exactly the same thing. You would have found out the time on both of them anyway. So what you would have done is this. If you want to do it another way, just using the graphs only, you say that's t. We would have found out that was 20. We would have found out that was 5 anyway. And what we would have said is this. A half, 20 times 40, because that's the area of A. The area of B is going to be what, guys? Length of the rectangle, which is t, by the height of the rectangle, which is 40t. And then the last one's going to be a half, 5 times 40. And that's the formula for the total distance. And what is the total distance again? 700. And you would have done exactly the same process. You would have said, look, that's 400. The end is 100. And that's 40t in the middle, equals 700. Bring it over, you would have got 40t equals 700. Equals 200. T equals 5. Okay, guys, so for homework,